Hi, I'm Dave DiNucci, and this is a quick video about what I've been doing for the last 20 plus years, or what Scalpel's all about, or what my book is all about. They all pretty much have the same answer. Scalpel started in the late 80s. At the time, I was just working on programming parallel computers, software engineering, so basically getting lots of computers to work together on the same problem at the same time. In the early 2000s, I recognized that all my insights were generalizable to other plans, not just programs. A program is just a plan, forward, gram, writing, a plan for a computer, and my work I figured could be generalized to plans of all kinds, even for people that require lots of workers to get involved. So traditional plans are one action or verb at a time. Most of them are expressed as a sequence of steps, like verbs. Some of them skipped or repeated under certain circumstances. But it's almost like recording or imagining and then generalizing something that's already happened to one worker. It all seems very natural because that's the way we speak and write and experience the world in sequences like that. Such plans are easy to reason about because there's just one thing happening at a time, and at each step we know what the next thing that's going to happen is. But the world is not that sequential. There's things happening all around us, and unlike the past, the future is not so predictable, especially with lots of workers. So to think that we can plan for exactly what's going to happen at every step is kind of pretentious. So can we express a plan where if multiple workers show up, we can quickly figure out how to best utilize them, or even if some of them will leave early, even if they may have different capabilities or go at different speeds. And regardless of how those workers are organized spatially, some far apart, some close together, that may also impact how they communicate with each other, or how fast they can communicate or send materials back and forth to each other. And even while allowing us to continue thinking about one step at a time as we're looking at the plan to figure out that it does what we want it to do. Can we express the plan where if we're working alone, we can skip to another step other than the next one listed if, say, some materials aren't available right now, or something else comes up, or we want to go to another plan right now. We'd like more flexibility than there is in existing plans. So who cares? Who really needs this stuff? Well, everybody to some degree. It'll help them to manage their own time and projects in this unpredictable world of ours. But the big demand really is from the software market. CPU demands and complexity for software are drastically increasing, as they've always been. But now we have AI, we have speech recognition, bioinformatics, weather and climate prediction. You've heard of the Go player that's beat the world's reigning Go player. Even all this is happening while CPUs themselves are not speeding up year to year. They're just getting smaller and cheaper all the time. So what's the answer? That means that for these big demands on CPU power, we have to continue throwing more and more CPUs at each problem, and yet the complexity of these problems is also great, so we have to limit all that complexity. And so this is needed by the software market. Programmers also require a lot of usability and expressiveness for whatever we give them, so if we can satisfy them, maybe we can satisfy anyone. So what have these people been doing so far? Well, very niche solutions. If they have fixed number of identical workers or CPUs in a very specific configuration, and they can give each worker some very specific thing to do, its own sequential plan, and tell it exactly when to talk to the other workers, etc., then sometimes they can get something to work right. Or they can try to use AI to basically take a plan or a program that's written in a sequential manner and make it work concurrently, make it figure out how to use other workers. That sort of AI has been worked on for a long time, and it's still not getting the job done. Or we can use new languages to express the plans that look kind of like sequential languages, but not quite, and are easier for an AI to turn into something that could use lots of workers. None of these really solve the general problems that I just outlined. So my stuff is called ScalPL, Scalable Planning Language. It uses several old ideas in new ways, actually. First, it doesn't list anything out. It's graphical. It's picture-based. although there is a textual form to describe the picture. Verbs and nouns are shown graphically, just scattered about the page. So they're not sequenced. It just shows the relationship of the verbs to the nouns using arrows to show how stuff moves between the verbs and the nouns, or how a verb moves things from one noun to another. Then for each noun, it shows the order in which the verbs can access that noun, or will access that noun, will affect the noun or be affected by the noun using colors. We also don't let a verb do anything until it can finish doing its thing. So a verb just sits there until it can finish doing everything it's going to do, and then it does it. Only one verb can affect any noun at once, so verbs can be understood one at a time, just like traditional plans. Okay, what does that all mean? Here's kind of a picture. This is a simple ScalPL plan for making and eating waffles. As you can see, the rectangles are the nouns. There's the ingredients down in the lower left-hand corner, the bowl up in the upper left, the waffle iron up next to that. Down below that, there's the table that the waffles are going to be served to, and the order sheet that the orders are made on. The ovals are the verbs. So we're going to mix the batter from the ingredients into the bowl. We're going to spoon the batter from the bowl to the waffler if there are orders. We're going to serve the waffles from the waffle iron onto the table. We're going to preheat the waffle iron, etc., set the table, etc. The colors tell exactly the order that these things can happen to each of the nouns. So for example, the waffle iron says, the preheat has to happen first, and then I'll accept something spooning into me, and then I'll accept something serving from me, and then I'll repeat those. So that's the basic idea. Add some formal theories, bells and whistles, and it addresses almost all the issues that I brought up. But these are just the basics. The diagram you just saw, the verbs are actually themselves plans. Those plans can be either sequential plans, like we've been doing all along, just traditional programs or plans, or they themselves can be other diagrams, high-level plans. So these diagrams can be hierarchical. There are lots of other rules in theory on top of this to satisfy the software market, especially. So in the end, these high-level diagrams or plans are now portable, scalable, structured, object-oriented, dynamically linked, reactive, functional, data parallel, component architectures of atomic transactions. And yet they're really efficient. That's the basic idea of what I've been doing. ScalPL, the status of it is I wrote a book in 2014, and I developed tools to help devise them, and a PhD dissertation, and it's all pretty much in the book if you want to know more. Thanks.